Number 20, write the first 5 terms of the arithmetic sequence, find the common difference, write the nth term of the sequence as a function of n. So we got 3 things to do here, the 5 terms, common difference, and then the formula for an. So again, what this rule says is no matter what term you're on, if I take a term and I add 5 halves to it, I get the next term. So if my first term is 15, then what I want to do is I'm going to add 5 halves to get the next term. This is where things can get a little challenging. One way to look at this is 2.5. So add 2.5, that's okay. Another way, personally, the way that I do, I like to look at this as 30 divided by 2 is 15. Now when I want to add 5 over 2, that's not a problem because I get 35 over 2. When I add 5 over 2 more, I get 40 over 2, which is 20. Add 5 more gives me 45 over 2. Add 5 more gives me 50 over 2, which is 25. So they're the first 5 terms. The common difference should be straightforward, I think. It's sitting right here. It's what we add between every term. So that's going to be the 5 halves that we got up here. Now to come up with our formula for an, I need a 0. So that would, again, that's the term before this first one. So we need to subtract 5 over 2, which takes me to 25 over 2. Sorry for the announcement. So an equals dn plus a0. So there's the formula for an. Here's the common difference. And then here are the first 5 terms. All right. 21, find the formula an for the arithmetic sequence, and then find the sum of the first 20 terms. So with a common difference of negative 3, that means a0, the term before this, would be 3 more than that, or 103. So then an is going to be negative 3n plus 103. Now remember, to get our formula for the sum of the first n terms of an arithmetic sequence is always going to be n over 2 times the first plus the last term. So that formula you will need to know. So to get the sum of the first 20 terms, n is going to be 20. So I need the first term, which we are given, so that's 100. And then I need the 20th term. Well, again, I have a formula that gives me any term you want. So if you want the 20th term, just plug 20 in. Negative 3 times 20 is negative 60. Negative 60 plus 103 is 43. I take those 3 values, and the sum of the first 20 terms is going to be 20 over 2 times the first plus the last term. (20 divided by 2 is 10. 100 plus 43 is 143. And you multiply a number by 10 by just tacking on a 0. So find the partial sum. So same type of thing. I need the first term. I need the n. Let's start with the n value first. N equals. I need the first term, and then I need that an term. So in this case here, we're going up from 1 to 8. So n is 8. So we need the 8th term. So let's plug in 1. So plug in 1. 3 times 1 is 3. 20 minus 3 is 17. And then I want the 8th term, so we're going to plug in 8. 3 times 8 is 24. 20 take away 24 is negative 4. So the sum of the first 8 terms is going to be 8 over 2 times 17 plus negative 4. 8 over 2 is 4. 17 plus negative 4 is 13. To get 4 times 13, if you double 13, you get 26. Double that gives you 52. In number 23, n is 25. We get our first term. 3 times 1 is 3, plus 1 is 4. 4 divided by 4 is 1 for our first term. And we need the 25th term, so A25. 3 times 25 is 75, plus 1 is 76. 76 divided by 4, well, half of 76 is 38. Half of that is 19. So the sum of the first 25 terms is n over 2 times a1 plus an. Now, one thing of kind of interest here is this fraction out in front being divided by 2. If the numerator is an even number, you can divide that by 2 and get a nice answer here. If this number is odd, though, and when you divide by 2, you're going to get a decimal of some sort. So usually what happens is this piece, the other factor over here, ends up being even and able to be divided by. So 1 plus 19 is 20. 20 divided by 2 is 10, times the 25 gives me the 250. You can do it any way you want, but you'll still get 250. But quite often, one of them will work out to give you the even number. All right, I'm going to stop here because we get into geometric sequences next.